Well, thanks, Travis. I'm really happy to be here with the team again today to talk about this really important topic. What can we do to use all the RAP that we generate in the best possible way? Of course, these webinars always kind of the flow follows the same pattern. I come in and begin the webinars providing track background on the topic. Then we have a PI, typically principal investigator, come in and provide a research overview. Then we try to bring people in from the industry to talk about deployment, and then I come back in at the very end and talk about the takeaways. What are the important things that we can take away from these topics? Of course, as I said, the background of all these implementation webinars is really based on the experiences that we have had at the NCAP pavement test track. Now, this facility is a 1.7-mile oval, and you can kind of imagine it as a ground truth giant outdoor laboratory. You can run lots of tests in the laboratory and do modeling and do predictions, but the test track tells us how things actually perform, and that's its purpose. So we rebuild this facility every 3 years. We've been doing that since we finished the first track in 2000, and that means that in 2023 we're working through our eighth research cycle. So once we build these test sections at the beginning of these 3 year cycles, we run a fleet of heavy triple trailer train trucks. Every axle that you see there, except for the steers, is loaded up to but not beyond the federal legal bridge limit, so that we can induce what's referred to as accelerated pavement damage, do a lifetime of damage or 10 million equivalent single axle loadings over the course of about 2 years of fleet operations. We run 5 trucks at a time in order to do this. And what this means is that when we're kind of optimally productive, we want to do 100,000 easels per week or 20,000 easels per work day, and then we shut down 1 day a week so that we can do out and do because we go out on the track and do detailed pavement condition assessments. So, with respect to the topic that we have today, I wanted to go through the history of the track and then pull out some very specific information before I hand it off to Ben. Today's format's going to be a little bit different because I'm going to go through the background and then step off into the research and cover the very first part of that, and then I'm going to hand off to Ben. But when we finished the first track, it was almost exclusively virgin mixes all the way around it. All 46 of the original 200-foot test sections were all but just a couple. There were a couple test sections that were low RAP mixes, but everything was hot. Virtually everything was virgin. In the first rebuild in 2003, we had some low RAP mixes in mill and inlays, and we did our first warm mix asphalt. Some of the first warm mix asphalt in the United States, in fact, was on that 2003 track. In 2006, we did our first, what I would classify as high RAP mixes. They were 45% RAP. They were mill and inlay test sections in the curves, in the west curve and the east curve. That project was very successful. So we went from there to, in 2009, we did some, as part of a bigger structural experiment, we did full depth high RAP test sections where we had 3 layers, all 3 layers, the base layer, the binder layer, and the surface layer. They were all 50% RAP. And in 2006 and 2009, we fractionated our RAP in order to hit our quality targets with those mixes. Based on this building history that we had in 2012, we built the Green Group experiment, and this was an experiment that had recycled ground tire rubber, reclaimed asphalt pavement, RAP and RAS in the study, all compared to kind of a traditionally built pavement, relatively thin pavement structures. And I've got that little CR abbreviation there to remind me that in 2012, that was when we did our first 100% RAP cold recycle mix that Ben is going to talk about quite a bit when I hand off to him. In 2015 and 18, we executed what we call the cracking group experiment. And by the way, in each of these research cycles, there were a lot of other things that we studied. I'm just referring to what's relevant for the topic today. And again, also in 2015, I've got CR in orange there to remind me to tell y'all that we ran cold recycle mix in our hot plant with a burner off after it had been allowed to cool down overnight. So that was another round of cold recycle mix that we did there. 2021, the centerpiece of that study was the additive group experiment. In the cracking group study, we got a lot of confidence in the ability of balanced mix design cracking index tests to match the performances that we observed on the track. So we moved that forward into the additive group, and in the additive group study, the purpose of it is to look at recycled ground tire rubber, recycled plastic in both wet and dry packages, and then also high strength aramid fibers compared to a control mix. So we understood the cracking test from 2015, 2018, and then we moved that forward to better our understanding of the impact of additives on the life of the pavements. So as you can see here, we've got a history of going from virgin mixes to low wrap mixes to high wrap mixes, in hot mix and in warm mix, and then to cold recycle. We've even done coarse fractionated wrap chip seals now several times on the track. And then I've got fine fractionated wrap microsurface shown there in orange because to remind me to tell you we've not done that yet on the track, but it's not because we haven't wanted to try it. It's just because we haven't gotten the chance to do it yet in a funded experiment. And the whole point to this, as part of the background, the whole point of this webinar is what we really want to do is stop the growth of especially the giant wrap piles in some of the urban areas. And then we want to begin to make them smaller through the best monetization of the wrap that is in those existing large wrap piles. And hopefully by the end of the hour, you'll have a good feel for what our philosophy is on that. So of course we believe processing and fractionation is essential if you really want to get the best use of the material, and I think you'll see that theme throughout the webinar today. And you can run hot and warm mix asphalt using wrap when you use balanced mix design practices. And of course, my personal preference for balanced mix design is just an old Marshall press with an IDT load head. This is a picture of one of the old plotter systems. This is actually ours at the track, but it since has been retrofitted with an electronic system so that it doesn't use the plotter anymore. But when you're running BMD tests, really simple BMD tests with this type of machine, you load these samples in indirect tension. When you run the sample at some elevated temperature, when you run it hot, the peak value gives you a strength indication that we believe correlates well to a loaded wheel tester. And then when you run it cool at laboratory temperatures, the shape of the curve it correlates well with the cracking that we've observed on the track. So you use these tools to design virgin mixes, and volumetrics served us well for a long time with virgin mixes, and there's volumetrics. Nathan Moore and I talk about this all the time. They're a great tool for developing mix designs, but they have less value for actually policing mix designs. But when you get into low wrap mixes and especially high wrap mixes, when you need to use best practices on your yard to do processing and fractionation, and you really need to respect wrap piles more than virgin piles in terms of your quality program on your yard if you want to run higher wrap contents. And then when you want to pull in, when you're running high wrap, that's when you might want to consider additives like recycling agents for using short-term and long-term aging, that type of thing. Cold recycle mix is another great use for reclaimed asphalt pavement, and I like to think that there are three different ways that we can use it. You can use it for lower performance, just using a recipe, using conventional values for binder contents and cement contents and that type of thing. And then kind of the conventional way is to have medium performance mix with a mixed design, and Dr. Bowers is an expert on that mixed design process. And then he and and Elizabeth Hiroshi are also working on some high performance cold recycle mixed designs. And wrap has a place in all of these approaches. I've already mentioned that we've done coarse fractionated wrap chip seals on the track, And at some point, we want to do a fine fractionated wrap microsurface, and this is a process that is used by some agencies out west, even doing Cape seals that are 100% wrap, where you use the coarse fraction for the chips and you use the fine fraction for the microsurface or the slurry seal overlay writing surface. So I want to go back to the Green Group experiment from the 2012 track. And I mentioned this in a previous slide, but there's a lot of really good stuff in this experiment. And really what I want to stress here is we used, Dr. Randy West was the principal investigator on this project, and we used perpetual pavement principles to put these test sections together. So it was 4 test sections in this study, and the control section was section 5 on the north tangent, kind of the all-American build up, 6 inches thick, 20% wrap surface, and then 35% wrap in the intermediate layer or the binder layer and the base layer. And then we had these 3 treatment test sections. Section 5 on the south tangent was high wrap. Section 6 on the south tangent was wrap and RAS, post-consumer RAS. And then section 13 on the south tangent was recycled ground tire rubber. When I say we use perpetual pavement principles, the idea with this was, let's put something that we think is going to be crack resistant on the bottom, where deep and expensive cracking initiates as a result of higher strain levels at the bottom of the asphalt, lowest layer of asphalt. Put something that's stiff in the middle to reduce the bending and the deflections and the strains at the bottom of the pavement. And then put something that's durable and rut resistant and renewable on the surface. That was the philosophy of this study. We were not trying to build perpetual pavements, but we were using perpetual pavement philosophy and practices to put these test sections. So as you can see here, where I've highlighted that lower layer, we used highly polymer modified binder in S5. We used lower wrap and a rich binder, elevated binder content in S6. And then we used virgin material in an asphalt rubber gap graded mix in S13. So for that lower layer where you're trying to prevent that deep cracking, you use a crack resistant hot mix asphalt, or you can maybe even use one of those lower performance cold recycle mixes that I talked about earlier. That lower layer typically in a perpetual pavement is 2 to 3 inches, but we're not building a perpetual pavement. We're just using the design philosophies here. The intermediate layer, were in all 3 of these cases, these were stiffer layers. We used wrap and wrap in S5, wrap and RAS in S6, and then recycled ground tire rubber in S13 to reduce deflections in the structure. So in that intermediate layer where you want it to be stiffer and strain reducing, deflection reducing, you can increase the wrap content in hot mix asphalt, or you can put a moderate performance type of a cold recycle layer in the middle, which we have done out on US 280. And then for these surfaces, which can be anything between a 1/2 inch thick and 2 inches thick at kind of at the extremes, you want something that's safe, smooth, and renewable in the surface. And that typically you should look at something that's a lower percentage of reclaimed asphalt pavement, and yet unless you're using things like recycling agents to improve the health of the binder. And we're even doing research now at NCAT to use high performance cold recycle mixes possibly as surfaces on lower volume roads, like for cities and for counties. And then when you've got that structure, then you can focus on pavement preservation. So this might be this is not necessarily a thicker pavement, because we're not promoting that type of a thing in this webinar. But then you can come back with preservation and maybe use a low wrap to no wrap thin lay, highly crack resistant thin lay, or you can use coarse fractionated wrap for a chip seal, or a fine fractionated wrap for a microsurface, and take care of the pavement preservation needs that you have on that pavement structure. Now, when you do that, what you see in this slide is that all 3 of those treatment test sections outperform the control, and the best performing test section that we had in this experiment was the high wrap test section. And in fact, it the ground tire rubber and the wrap and the RAS kind of ran together there. But again, all three were better than the control. So at this point, I'm going to end this part of the presentation, and I'm going to hand it off to Ben so that he can take a different direction with the research, and then I'll come back at the end and tie everything together from research and then also deployment.
All right, everybody. Well, thank you once again for being here. And I am going to talk about kind of a different perspective and highlight more on that cold recycling and also some other uses of wrap that I've seen that have been particularly impressive, despite maybe how I thought they would perform. So why don't we start there, right? So what are some uses of wrap to get rid of some of these large stockpiles, but not use them as simply fill material and, God forbid, landfill, right? Like, we don't want to be doing that. And I remember from my time in Virginia, there was an idea that was proposed that, I'll be honest, and I told the person who proposed this, I thought it was kind of crazy and maybe a waste of time. And that was actually using wrap on unpaved roads. And what was proposed here, one of the issues that they were having in some of these secondary roads was they were gravel roads. They were dealing with winter maintenance issues. They were dealing with, after major precipitation events, they deal with washout. And it was costing the DOT a ton of money to get out there and actually regrade those roads. So what they thought about doing was, well, because we can't afford to actually pave this road, and there's a lot of political things, board of supervisor approval, things like that, to actually pave a road and maintain it, they looked at, what if we took wrap, which still has that asphalt binder on it, that we can actually meld it back together and use it as a gravel road that will be a higher performing gravel road. And so what they did was they took 100% wrap. They added water. For those of you who don't realize, you can run an AASHTO T180 Proctor on wrap and you'll get an optimal moisture content for wrap. So they added water, and then they placed this wrap out on top of this gravel road, as you see here, of course, after grading it. And then they compacted it with a steel wheel roller. And they created, interestingly, a final product that looked a whole lot like a really old road. And so you see that picture here on the right, that's a picture. Now, what's important is that the wrap binder actually causes those aggregates to stick back together. Even though it's stiff and it's oxidized, what was really cool is that locals were really pleased to have their road paved, which they had not had their road paved, but they thought they did. So there's kind of a social benefit here, but ultimately it ended up saving money. And the reason is because when they started dealing with major rain events and things like that, that wrap binder was actually sticking the aggregates together still, and so they weren't dealing with as much washout and issues like that. None of the major rutting and things that we experience in major precipitation events. So this is a positive effect for these folks, and it's a way to also make our pavement leverage this asphalt that we already have. Do I think this is like the top way that we should be using wrap? Well, no, but the fact of the matter is, most of our infrastructure is built, and right now we're trying to increase our wrap contents, but we're not at 100% wrap. And so we have more wrap stockpiled than we actually have time to use, or places to use. So how can we actually move forward and use this in a beneficial way and continue to use it as a pavement? And I think that's a really important takeaway. So I wanted to highlight that because I thought it was kind of a cool example of something that was done that was a little bit outside the box, that again, at the time I thought was kind of crazy, but it actually worked and folks were actually pretty satisfied with it. So kind of stepping now into a little more of a designed mixture, a direct application to our not only low, but our medium and high volume pavements. I'm going to talk about cold recycling. And Buzz set me up nicely talking about, the work that we did when I was or Travis actually talked about the work we did when I was in Virginia. I continue to work with those folks, both on the test track, as well as on some other projects focused on cold recycling and ways to enhance or ways to better understand cold recycling technology and techniques, and ways to enhance its use so that we can be using it in more applications. So as a reminder, for those of you who aren't familiar with cold recycling or don't remember it, cold recycling consists of two methods. Basically, we're going to use 100% wrap, and we're going to do it either in place, which is called in-place recycling, or we're going to use the material pulled out of the road or stockpiled in cold central plant recycled material or cold central plant recycling. You produce the exact same mix, but one uses a mobile plant, the other is done actually on site. Now, it's a combination of wrap, water, which throws all my hot mix folks off because we don't like water in our hot mix asphalt. But again, it helps us to get a maximum density. You get 2 to 2.5% binder. That's either in the form of a foam or an emulsion. And sometimes we'll have 1% of an active filler. This would be something like cement or lime. And that's really to add fines, enhance some of the early strength gain. And this whole process is done cold, so we're not adding any heat or anything of that nature. And so what's really important to take away here is that this is a hybrid material. So this is taking what we learned in geotechnical engineering, subgrade, and subgrade stabilization in our aggregate-based materials and combining it with what we know about hot mix. So with that in mind, I want to show a couple of pictures. This is from the I-81 project in Virginia. So Brian Diefendorfer actually took this picture. This is called in-place recycling. And so what you see here is the recycling unit, which is the big white thing. Let me get my highlighter here. So this right here is our recycling unit. So it is doing all the mixing of the asphalt binder, the cement, which is that active filler, which is laid out in front. So they used a cement spreader for that. And then there is a water tank on this unit that is adding the water needed to get the optimal moisture content. It is mixing everything up in here. It looks a lot like a milling unit, but it's not pushing everything to the center. And then it gets ejected out of screed in the back. And then we pave it just like anything else. We can do this only, so keep in mind, cold recycling only in the bound layer. So it's 100% wrap. We're not getting into that aggregate base. We're not getting into the subgrade. That would move us into a full depth reclamation process. And with CIR, we're typically 2 to 5, maybe 2 to 6 inches thick. There are some newer recyclers that can go much deeper than that. But
excuse me,
practice.
we can't see the slides.
You can't see the slides.
All we see is the first slide.
Oh, weird. Okay, hold on. Let me try this again.
I can see him just fine.
Now we see them.
We back? All right, thank you. I see now a bunch of chat showed up here, so sorry about that. All right, let me know if you have any other issues. Thanks. All right, so this is our recycling train. This is a single unit recycler. There are multi-unit recycling trains. I don't have time to get into all of that, but I can point you to some helpful resources like the Basic Asphalt Recycling Manual by ERA that can show you all that, or you could reach out to me afterwards and we can have more conversations. Hopefully you see my slide change. This is cold central plant recycling. So this is that mobile plant. It can be hauled anywhere. It gets set up. It is, I mean, you can actually see the tire. So it is an actual trailer. We're still having slide sharing issues, it sounds like. Stacy, can you see this? My slide change?
Yeah, I can see it fine.
Okay.
Yeah, I see it changing as well, Ben.
Okay. So maybe there's some lag issues that I learned that happens in COVID Zoom world. All right, so we could use newer existing wrap. Typically, again, you know, that 3 to 6 inches, but we could also place it in multiple lifts. So you could have, you know, multiple 5 or 6 inch lifts put down with this material. You simply load it, in this case, into a front end loader or into the back of a dump truck and haul it out and place it using a typical paving screen. So let's talk a little bit about the research that's been done down here. Buzz alluded to it earlier. In 2012, NCAT was getting ready to do a new test section. And so what they were doing was, or a new test cycle, VDOT wanted to experiment with what they did on the I-81 project. And so they brought all their materials down here and built 3 test sections. 2 of them had 5 inches of CCPR, one with the 4-inch asphalt overlay, the other with a 6-inch asphalt overlay. And then the third one had 8 inches of cement stabilized material with 5 inches of CCPR and 4 inches of asphalt on top. Now, what's really interesting is that after 30 million easels, so we didn't think this was going to last, more than one track cycle. After 3 track cycles, so 30 million easels, the section that had the stabilized base under the CCPR, so using an FDR process, actually performed according to our experience with perpetual pavements and measuring tensile microstrain, which is some of the work Dave Tim has done, as a perpetual or long life pavement. So as you're looking at this, what we're seeing is the cumulative percentage of strains in the y-axis and the x-axis. We're seeing the tensile microstrain. If you're to the left of this line, that means your strains are low enough that you're not going to get fatigue cracking. And so in this green case, which is that S12 section with the FDR base, we are seeing perpetual performance. Now, interestingly, we were not until right at the end seeing any cracks whatsoever in the 4-inch section, or the 4-inch asphalt section over 5 inches of CCPR. So this was not actually performing as a perpetual pavement from a strain standpoint, but we weren't seeing any cracking, which was actually very surprising. So we do believe that the S4 or the section with the CCPR over the FDR base is a perpetual section. We actually took that offline. And then the section that had the 4-inch overlay over the 5 inches of CCPR with no stabilized base, which is over aggregate base, was not deemed to be perpetual because we've started to get some cracking. But it did go basically 30 million equivalent single axle loads before we got any cracking, and we've actually continued. So in the future, we'll have an update on how that's going, and it is progressing along. So let's talk real quickly about how do we use this? Like, what's the implementation outcome? So when I was at VTRC, we found out about a project that we were wanting to widen the Interstate 64. This is basically from Richmond headed out towards the beach, so going through like Colonial Williamsburg. And what they wanted to do was widen it and either rehabilitate or replace the existing concrete pavement. So Brian and I drove down to Richmond and showed them all this data from NCAT, and also had run some numbers and provided those and said, would you all consider implementing this cold recycling and FDR approach that we had that gave us a perpetual pavement? And the good news is it was a design, not a design build. It was a special project. So they put out a concrete option, an asphalt option, and a recycling option. The recycling option actually won the bid. So 15.38 total miles. It's a new lane to the inside plus a full wet shoulder in both directions, and then reconstructing the existing lanes. If you were to look at the recycled design, we have 4 inches of SMA over 6 inches of CCPR. There is a 2-inch open graded drainage layer in between the CCPR and then a 12-inch FDR. So this very closely mirrors what we used down at the NCAT test track and saw great performance with, as well as what they did on Interstate 81 in Virginia and have had excellent performance with. So what I like to highlight is the way this was implemented actually helps to minimize traffic impacts as well as enhance safety. So this is our existing concrete lanes. You have 2 lanes along with a median. They put up a safety barrier, and then they constructed the new cross section. So this recycled cross section. Now, you might be thinking, how on earth did you do full depth reclamation when you were in the median? What they did was they actually brought in a combination of wrap or recycled concrete aggregate, basically graded everything, laid it out, and then ran the reclaimer over it and basically imported the FDR. So we've been referring to this as imported FDR, placed the CCPR, and then the asphalt surface. Then they opened traffic. So we had the same traffic capacity, just moved everybody to the left side of the safety barrier and reconstructed the existing. And at the end of the day, 3 lanes, 2 new shoulders. And this is a picture actually of driving on the new lanes and the new full width shoulder. But at the time we were using both as lanes while they reconstructed the outside. So a couple of really important things or important takeaways here is total cost savings are estimated between 10 and $15 million for this project combined. Some calculations were done and it looks like we're saving energy roughly 25 to 45% compared to traditional alternatives, as well as 15 to 40% in terms of our greenhouse gases. So thinking about everything we know about life cycle assessment and EPDs and things like that, a real benefit here. And then finally, looking at the amount of material that was used, and I really want to focus here on the CCPR here at the bottom. This used over 350,000 tons worth of wrap went into this. That is a lot of wrap that was able to be used as a high-performing, high-traffic interstate pavement. And so this just shows a good example of how we can be using 100% of our wrap and incorporating it back in. Now, keep in mind, this was new lanes and an old concrete pavement. So it's not like we generated a bunch of wrap in the process. So thinking about some of these applications for lane additions, shoulder additions, and reconstructing existing pavements can be really beneficial. Brian put together a cost comparison to what was going to be the traditional HMA. So the HMA design called for 12 inches of asphalt concrete over a 2-inch open graded layer, over 8 inches of cement treated aggregate. In both cases, the structural number was within 0.02 using VDOT structural layer coefficients. However, the difference in cost was $83 for the traditional asphalt approach versus between $40 and $61 per square yard for the recycled approach. And you might ask, what's the difference? It was higher. So the 61 reflects actually having to import that FDR. So actually having to truck in the wrap and things like that that were used to make the new lane. But in the outside lanes, they didn't have to do that. So the last thing I want to hit on real quickly is some work we're doing. And you heard Buzz talk about high performance cold recycling. We reconstructed our off-ramp during the last test track cycle. Basically, what we were interested in is what happens if we add a rejuvenator to CCPR. We've been getting that question a lot. And based on the experience we have, we knew it would be somewhere between hot mix asphalt and traditional CCPR. So what we did was we put down 4 inches of hot mix, 4 inches of foam CCPR, which is quote unquote traditional, 4 inches of an engineered emulsion CCPR. And then we had 3 sections, each with different styles of rejuvenators. One was an emulsified bio-based rejuvenator. One was a straight rejuvenator with no emulsion. And then one was an emulsion where we added in a rejuvenator. Now, as I said, this question's been asked a lot, and this shows a little snapshot of some of the work we did. What you're looking at here is a dynamic modulus curve, so stiffness. Essentially on the left side, we're looking at higher temperatures. The right side, we're looking at lower temperatures. And what you'll see is based on some of the mechanistic tests we had run for other projects on traditional or typical cold recycled mixes, they performed with in terms of stiffness, much lower than what we see in a typical hot mix asphalt base mix. So what was interesting is when we looked at a rejuvenated CCPR, it came out somewhere in between. So those black squares are the rejuvenated mix. And you'll note it's between the cold recycled and a hot mix. So we thought, well, that's interesting. Is that a good thing or a bad thing? We don't know. So we wanted to experiment with it. So we brought in 2 different plants. One was the Wirtgen cold recycling KMA. Another was just a portable pug mill that was brought in. And the traditional or typical cold recycled mix styles use the KMA, whereas the rejuvenated mixes, the folks who brought those rejuvenators down elected to use the portable pug mill. They do basically the same thing. So there was no concern about getting major differences between them, but it did show some different applications and thinking about where we might do this. Construction pictures, basically we constructed this just like hot mix with the exception of we compacted till refusal and it wasn't hot. Our densities were much lower for this material compared to hot mix as well. So we were hanging out in like the 130 pounds per cubic foot or high 120s pounds per cubic foot instead of up in like the 140s. In terms of performance, a couple of things to note here. For the most part, everything's tracking along in terms of running as we expect, but you see that our emulsion plus our rejuvenator does have significantly more rutting, and then our straight rejuvenator also has some additional rutting. When you look at our international roughness index, the one that is a straight rejuvenator has a little higher IRI, but it seems to have stabilized. And the one that was an emulsion plus rejuvenator is literally off the chart. Now, why is that? We believe that it had to do with the emulsion type that we used, as well as excess moisture in the mat and needing longer to cure. We know how we're going to correct this moving forward. And so if we end up doing significant maintenance or rehab here, we're going to shift gears a little bit, because what we've seen is that the other sections with rejuvenator, they're performing just fine. So we don't think this is a you shouldn't use rejuvenator, but this was new territory. It had never been done. And so we were really, in a lot of ways, experimenting in mixed design and then taking that to the field. So some helpful lessons were learned, and we'll continue to update you all as we round this out. So with that said, contact information. For those of you who can't get the slides, we're happy to share those, and Travis will be the person to talk to about that. But now I'm going to hand it over to Stacy.
All right, let me share screen. All right, can you guys see that okay?
Yeah, that looks good, Stacy.
Okay, great. Okay, so I guess kind of to follow up with Ben, to piggyback on this, I don't know, I don't remember, I guess it was a couple of years ago that you guys were doing a presentation about this similar thing, and I had just mentioned that we had done some of this in Texas, and so then I guess we've kind of done a couple of these together since. So I'll jump right into it because I don't think we have a ton of time. To give you a background, when I worked for a large family-owned asphalt producer here in Texas several years ago, they sold in 2021. And at the time of the sale, we had almost 2 million tons of RAP in inventory. And we have several challenges that we face here in Texas. And one is that the TxDOT specifications have kind of gone backwards on RAP usage. You know, everybody's concerned about sustainability and decarbonization, and, everything's moving in that direction, but our specifications in Texas are not following that necessarily. And so a lot of surface mixes, several districts by general note will not allow RAP. And so what happens is we have a 50,000 ton mill and overlay job. We just put 50,000 tons of RAP in our inventory. And so Ben's already kind of covered some of the benefits of using RAP. I'm just going to talk about specifically, why we got into some of the things we did or tried here in Texas. And that was one, hey, what can we do with all of this RAP? I've already kind of talked about, why we took a look at this, these options and some of the challenges. Another challenge we faced is, if some of you may or may not be aware, was early last year, the Vulcan quarry in the Yucatan was basically seized by the Mexican government. And that took about 8 million tons of aggregate out of the Texas market just overnight. It was just gone, and 8 million tons a year. And so then that particular, burden fell on Texas quarries that are already operating at capacity. And so then the rail's a challenge, everything's a challenge. So we're going to have to be more creative. We're going to have to look around and look at the materials and the inventories we have. And so I already kind of talked about the problem and the specifications and how we've been greatly limited kind of coming back around with more of the balanced mix design studies. But we're still very challenged. And so several years ago, my bosses came to me and said, "Hey, Stace, is there something we can do with all this wrap?" And I was like, 100% that we absolutely could. And so years ago, I had done a lot of work with the emulsion industry here in Texas on full depth recycling, on cold in place, on, several of those processes that had kind of fallen off. It's fallen off a little bit. And so I reached out to some of my friends at Ergon, and we talked about what our options might be. And so we came up with the idea of doing cold central plant recycling. Years ago, we did some cold in place recycling in Texas, but that kind of, like I said, it just kind of went away. So we took a spec, an old cold in place recycling spec, and kind of modified it to be more of a cold central plant recycling. So this is just kind of where we were, the options. Ben's already covered, where these things can be used. So in late 2018, with the help of Ergon and then Paragon, their technical service group in Mississippi, they took our wrap, and we just we're coming up with a list of options: cold central plant recycling, using it for chip seals, using it in microsurfacing. Mostly, I'm just going to talk about the cold central plant recycling. So we did a design with 100% wrap. And the idea was, could we come up with, we have a hot mix cold lay spec here, which is like a cold patch material. It can be it's mixed hot, but it can be stockpiled for up to 6 months and used. It's a maintenance mix. And so we thought, could we do this for some of our county guys? Could we get a special spec with TxDOT? Because interestingly, this maintenance product, this maintenance material, doesn't allow zero wrap. So it's very interesting that this is a maintenance mix, and the TxDOT spec does not currently allow any wrap in their cold mix. So anyway, we wanted to see if we could come up with something that was 100% wrap that we could stockpile, right, and use in a similar fashion. And so we tested it, and we kind of modified between the cold central plant spec and some of the hot mix specs, and used the Hamburg wheel rut test, and which is not currently in the cold mix specification. But we were trying to come up with somewhere in between cold mix and hot mix and cold in place recycling, kind of thing. So we used an emulsion. It was about 3% emulsion. We did the designs at our New Braunfels plant at the time, and we went over 6,500 passes on the Hamburg wheel rut with this mix. So for a standard hot mix, type D, 1/2 inch, 12.5 millimeter, however you refer to it, in the San Antonio district, the required passes are 5,000 passes, and we went 6,500 with 100% wrap and 3% emulsion. The challenge was that was going to be for immediate use. You could not stockpile it. And so we basically, in February of 2019, just ran, like I think Buzz mentioned, we just ran it at our hot mix plant. We didn't turn the burners on. We had the emulsion tanker there. We ran it off the truck. And then we placed it with a conventional paper in a parking lot at our main office there. And so you can see there it is in the paver, then rolled it, constructed in the same fashion that Ben talked about in his presentation, just built it like it was a conventional hot mix pavement. And it turned out really well. I mean, we were excited about it, but we wanted to get to where we could maybe stockpile this. So then the guys at Paragon went back to work, added a rejuvenator to the emulsion, and that seemed to give us about a 3-day window, not anywhere near the 6 months that was in the current cold mix spec, but to give it a few days, that was, we thought that was interesting. And so then we also changed up the mix design a little bit, where we did a 95% wrap and 5% man sand with the emulsion with the rejuvenator in it. And that material, just by giving it a little more of those fines from the man sand, we actually went over 11,000 passes on the Hamburg. Now, the standard TxDOT spec statewide is for hot mix with 64 minus 22 is 10,000 passes on the Hamburg. And we got 11,000 passes with a 95% wrap, 5% man sand, and the 3% emulsion. We did get a draft special spec done in the Austin district in March of 2020. And then it was March of 2020 and lockdowns happened, COVID's crazy. Everybody's working from home. And so the spec, it just kind of died on the vine. But we did have that in place. We're working in that direction. And so it's something that could 100% be revisited. But there was a lot of potential. A lot of people were excited about it. We had a couple of counties very interested in using the product on their county roads. They saw the benefit, and we saw, it was most likely easier to get in with local agencies and get this going than it would be with TxDOT. But again, COVID kind of just put a damper on a whole lot of things for everybody. Another thing that Paragon looked at was the use of the material in microsurfacing. And so we teamed up with Ergon and the city of Baytown and Intermountain Slurry Seal. And we put down in April of 19, 100% wrap microsurfacing on a city of Baytown project. And there it was, just kind of going down. We kind of did a little test where one side we rolled and the other side we didn't, because in a typical microsurfacing process, you wouldn't roll it. So we wanted to see kind of the difference between the two. With the emulsion, it was a little heavier than the typical microsurfacing applications. And so, we were just kind of seeing what we did with that, or how that worked. And so one lane was rolled, one lane was not. And, today this material is still performing. So that was April of 19. And so it's been down for a little over 4 years, and it's still doing quite well. And so the interesting thing about that is that the microsurfacing specification in Texas calls for a 100%, it's a SAC-A aggregate. And it's a 3/8 minus. There's like one quarry in Texas, in Central Texas, that will manufacture that particular aggregate. And so these guys are hauling that harder rock from Central Texas to wherever they're working in the state. And so that's very interesting, because, if you see this roadway, this is a city roadway. Why are we going to use our harder, higher quality aggregates on a slow speed roadway? We're not concerned about skid resistance here, right? This is 35 miles an hour. And so you just really have to look at the application. And I think there's a lot of opportunity to get out there and do more of this kind of pavement maintenance and preservation type thing. Another thing we looked at was the use of screened wrap and chip seals. And that was the thing that had counties most excited, because if you've got, we do a lot of pre-coated aggregate in our chip seals. And if you get into the middle of summer in Texas and it's, above 100 degrees, I think right now we've had 18 straight days of plus 100 degrees. And you get to about 2 o'clock in the afternoon, when you shoot those chip seals, you've got that emulsion down and you have a freshly pre-coated aggregate, you'll get a sheen, you'll get a little bleeding, you'll get a little, some flushing in some of your chip seals. And the thing the counties were most interested in was the use of this. And we did screen some material to be like a grade 4 chip seal rock. We did screen the material to be the individual sizes. Is that this is an oxidized material. And so it's aged, it's oxidized, and it'll work just as well as your pre-coated aggregates. And, it's going to have a cost savings, probably just as good, the performance will be just as good. And so, I mean, they were very, very excited about this. But again, it just kind of COVID and a lot of these things we were doing, it just kind of went away. And so, as we talked about, some of the challenges we face are that wrap inventories are growing and everybody's interested in sustainability. Everybody, we're having to do these environmental product declarations and, really kind of make a huge effort to, I guess, support the climate. And our specifications really limit asphalt producers or material producers a lot of times. And so when we look around at what we have available and you look around at your industry partners, a lot of this that we were able to achieve, we couldn't have done without the support from the technical folks over, at Ergon and Paragon. And, there was a lot of opportunity, a lot of potential. Here in Texas, we have a lot of a hot mix type B, which is a 1-inch material that they'll use and do, 8 to 10 inches of this material, followed by the surface, whatever they're putting on the surface. Well, the bottom lift is usually exempt production, blade laden exempt production. So they're not even going to really test it. And so why put our higher quality aggregates in hot mix down at the bottom when we have plenty of other materials available that would do just as well, whether it's through a cold central plant or, whatever. We could do the high wrap, we could do a combination of wrap or crushed concrete, like Ben mentioned, we have a lot of other things we could put down there in the bottom where, they're not going to test it like a conventional hot mix. And so, we're not getting more rock. We're kind of, we've got what we've got. And just with all of the challenges we face on material supply these days, just look around, we have it there. We have the options, we have the background, we have the experience, and we've got a whole lot of smart people that could come up with a whole lot of, pretty cool things for us to do. And so I think, just working with your local vendors, material suppliers, your local agencies, states, just making people aware of this kind of work that everybody's, been doing. I think there's a lot of opportunity for all of us, kind of anywhere. But with that, that's all I got. And then I guess I will send this back.
Minutes here to pull everything together and emphasize some implementation takeaways on the subject that we have been addressing today. Well, first of all, the track is I think you can see is a great place to do mix and materials research, structural pavement design, and then also pavement preservation when you want to consider and vet innovation in agencies of all different sizes. And over the course of the past hour, we've talked about virgin mixes, low wrap mixes, high wrap mixes, cold recycle, coarse fractionated wrap chip seals, and fine fractionated wrap microsurfaces as options in ways that you can monetize any kind of excess wrap that you might have on your yard. Fractionation is a processing and fractionation can be a great investment. I know you have to have the space to do it. But when you can, you have fine fractionated wrap that has a really high binder content. You have coarse fractionated wrap that's kind of a black rock that makes a good chip, and you can also use it as a pre-coated aggregate as specifications allow in the gap graded mixes or the coarser graded mixes. And you really want to focus on monetizing this, on taking advantage, of converting a liability in some cases to an asset. One of the other things that we emphasized earlier was that even if you're not building and maintaining a perpetual pavement, you can use the principles of the three layers that I think Dave Newcomb kind of pioneered decades ago, according to Dave Tim. You can use those principles to apply to all flexible pavement structures. And just to reiterate that, you want a crack resistant bottom, you want stiffer middle layers, and you want a renewable surface. And there's lots of options for that. Cold recycle mix, as you heard from Ben, that can be a crack resistant bottom because you don't have the same kind of brittle fracture properties that you have in hot mix. And high wrap content's a great way to get those stiffer middle layers. And then you also, of course, have options for renewable surfaces. And one of the things that I really like about what Virginia has done and what Ben did with Brian Diefendorfer and the team up there when he was in Virginia is the benefit of combining reclamation and recycling and then virgin materials or lower wrap content materials and methods in order to meet high performance demands of the job, like the interstates that have been done in Virginia and are now being done in some other jurisdictions as well. You've seen the experience that we've had on the track, as well as some good examples of some real world deployment. So these are practical and these are successful. Again, you need to school yourself up on the quality control practices that are necessary with your materials. And the big thing that I tell people when you start running high wrap content mixes in hot mix or warm mix, you really have to treat your wrap pile with even more respect than you do your virgin materials, because they're going to affect you on the gradation side and on the volumetric side as well through the binder content. And of course, all of this, as we like to say at the end of all of our takeaways for every webinar, it's really all about safe and sustainable asphalt pavements at the lowest possible life cycle cost. And we think that this topic is a great way for you to do that. Our contact information is shown on this slide, and I don't know why, Travis, I left your contact information off of this, but Travis can also be contacted through NCAT. But we appreciate your time today for this webinar, and we always like to take a moment at the end to promote the end of cycle track conference that we'll be hosting next May 7th, 8th, and 9th. Here at NCAT, please mark that on your calendars so that you can help us to avoid conflicts. And we'll be really excited to have everybody here with a couple of days of technical sessions focused on implementation, and then tours and demonstrations and that type of thing. We also like to support Training in Your Pocket. That's Travis's program, short and entertaining and amusing videos that provide you with basic testing information. It's a great way to kind of bring new technicians up to speed and kind of help them learn the ropes. I also want to remind everybody you can register for these webinars through NCAT's LinkedIn page. You can register for the NCAT implementation webinars as well as the preservation webinars for which Dr. Adriana Vargas is the PI. And finally, our next webinar in this series, in the track implementation webinar series, is September the 21st. And that's, again, going to be from 10 to 11. We keep it in the same slot to help you to keep that on your calendar. That's going to be very practical. It's all going to be about sample preparation for performance testing. So we hope to have the experts from the NCAT lab involved in that so that they can help you to get to reduce the variability in your results through really good sample preparation practices. So with that, Travis, I'm going to hand it back to you for a question and answer.
That sounds good. Thanks, Buzz. Appreciate that. We've covered some really great stuff today. I think there's some fantastic ways that we can use the wrap there. Really, one of the only questions, one thing I did see in here is that Pennsylvania actually has used some wrap micro this last year. And so I think that's really exciting to see. And then there's been some trouble getting some of the equipment that folks would like to use. Again, I put my email in the chat box. Feel free to throw me an email, ask for the recording, or ask for the presentations, and I can get those out to you. Stacy, thank you so much. The work